Now we will be dealing with the score modules. So first of all, we would be finding the score model module by using the search box, and afterwards we would be dragging the score model down here, and we would be connecting the tree module that is connected to the two class boosted decision tree module to the left input port of the score model module. Afterwards we would be connecting the right execute script model to the right input of the secure model. So here the train model would be connected here, and the executor R script would be connected here to the secure model in this way. The secure model module can now take the credit information from the testing data and run it through the model and compare the predictions the model generate with the actual credit risk column in the testing. Now it's time to make another secure model. So here what I would be doing, I would be just copying this secure model, and I would be creating another secure model. So here we would be connecting the output of the SVM model with the train model, and the normalized data would be connected with the secure model, and the training model would be connected to the secure model. And with respect to the normalized data, we would be connecting it with this execute R, and the another normalized data we would be connecting with the execute left side of our script. So what is happening here? With respect to the two class boosted decision, the execution is simple. Execute R script connected with the two class boosted decision, and then train model, and then secure. But with respect to the SVM model, what is happening? Here we would be needing two normalized data. One normalized data we would be connecting with the execute R script, and then that normalized data would be training the model, and then that would be feeding to the secure model. And with respect to this right execute R script, it would be connected to the normalized data, and that would be fed to the secure model. And with respect to the secure module of the two class boosted decision, the execute R script would be included, but in class of a SVM, the secure model would be linked with the execute R script through the normalized data and then train model, and then it would be linked. So it would not be linked directly. So for the SVM model, one has to do the same transformation to test the data as one did to the training data. So we have to copy, as mentioned, we have to copy the normalized data, and we have to create the second copy and then execute the R script. In this way, we would be able to connect the left R script and the right R script. Now we have to run the experiment and check the results, and afterwards we have to add the evaluator model. So for that we would be searching the evaluator model, and we would be dragging it onto the canvas, connecting the output port of the secure model from the decision tree and secure model associated with the boosted decision tree to the left input of the evaluate model, and connect the other secure model to the right port. And afterwards we would be running the experiment, and we would be checking the result. And we can see that after running it successfully, we can evaluate the result. We can click here, and then we can visualize the results. To check the result, click on the output port of the evaluate model and then visualize. The evaluate module produces a pair of curves and metrics that allow one to compare the result of the two secured models. One can view the result as a receiver output and precision recall curve or lift curves. Additional data displayed including the confusion matrix, cumulative values for the area under the curve, and other matrices would be shown. One can change the threshold value by moving the slider left or right and see how it affects the list of a matrix. So one can slide it here. To the right of the graph, on clicking, if we scroll to the right of the graph, then on clicking the scored data set, a scored data set to compare to the highlight of the associated curve and to display the associated metric below could be done. In the legend of a curve scored data set, as we can here notice in the legend of the curve, the scored data set corresponds to the left input port of the evaluate model. In our case, this is the boosted decision tree model. Score data set to compare corresponds to the right input port, the SV model in our case. So when one clicks on these labels, the curve for this model is highlighted and the corresponding metrics are displayed as shown in the following graph. By examining this value, one can decide which model is closest to giving one the result one is looking for. So one can go back and iterate on the experiment by changing the parameters. So the science and art of interpreting these results gives an idea to one how to deal with these evaluation matrices. Now it's time to deploy the model. So in order to deploy the model, we have to, first of all, whatever model we have created, we have to click on the setup a web service, and on clicking the setup as a web service, it will create the output as this, web service input and web service output, and it would refine that model and it would create a modified kind of a model. But one has to make sure, in order to deploy the model, that here I have eliminated all the training models, except I have kept only the class boosted decision tree, 2 class boosted decision tree, and I have eliminated other. So that has made my work easier. So now on clicking on the deploy, so the program would run, and it would generate this kind of a page, and where the model would get deployed. As one has noticed, the deploy web service has generated this page, and on clicking the desktop preview, it will ask me to feed the data. And here I would be feeding the column 1 to up till 21 respective data, and that would be giving me the test output. One can input the data manually, but the computer itself would input the data by itself as well, and here we can request the response, and which would help, and through this way we would be able to test our model. So here what we have done, we converted the data to the, on clicking on the deploying, what we are right now doing, that we are actually saving the training experiment to the predictive experiment. In this way, we need not to train our model again and again. We would be saving the model which we have already trained, and then we would be using or feeding the data, test data inside to this model, and we would be getting the appropriate values. So as I've already explained, that I have used the 2 class boosted decision tree, and then I trained and split the data, and then I executed, and afterwards I deployed the web service, and on my dashboard this thing became visible, the German credit risk model modified. It got visible after I eliminated every other model, and then after launching the setup as a web service. Now on requesting the test, I would be getting the appropriate result. And so this is a brief description how one can start a journey. One can take a data, and then one can edit the metadata, then split it, data training and testing, then execute the R scripts, and how one can use the different kind of regression models, and then train the data, and then score those models. Like one can differentiate between the two or more modules, and one can analyze at which regression model is best, and afterwards evaluating the result, one can analyze that which model or which regression technique or which classification technique is working well. Afterwards one can choose the appropriate regression technique, and one can deploy the model, one can set up a web service, and one can keep the service on the dashboard, and afterwards one can test any kind of response and test any kind of data and get an appropriate response with respect to it. So this is for the German credit risk model. Thank you so much for listening to the presentation. Thanks a lot.